Good morning, students. Now it's a second year maths, and we are doing calculus. That is first part of the calculus. That is limit and continuity. Continuity and differentiability is the name of the chapter. So let's start. We have finished up to this one question number 20. So after that I have showed that trigonometrical function, that is sin x, is it continuous? So last day we have seen, yes, it is continuous. Cos x, tan x, these are all continuous. Then we will proceed to our question number 21. Question number 21, it is written like that: discuss the continuity of the following function. That means you have to say whether this thing is continuous or not. First one is fx is equal to sin x plus cos x. So question number 21 of exercise 5.1. First part is what? First one is fx equal to sin x plus cos x. Now in this question you will answer on the basis of this mark. I have said what? Mark is a matter here. If you find that they have asked the continuity of this function and mark is given 1, then you will proceed in one way. If mark is given more than 2 or 3, then you will proceed in other way. So let's see how to do this one. So we have that day, that is last day, we have done what up to that the function is sin x is continuous. Now cos x is also continuous, that we have learned. And if mark is given less, then we can say let gx is equal to sin x, hx, another function, be cos x. So we have taken two functions. One is gx, which is sin x, and hx, it is cos x. Therefore fx is what? Gx plus hx. So this is our function. What is fx? Fx can be now written as sum of other two functions. Now see, gx, sin x. Last day we have proved that sin x is a continuous function. Cos x is also a continuous function. And one theorem is there. Theorem is like that: sum of two functions, continuous function, product of two continuous function, difference of two continuous function, then this fraction, provided this should not be 0, are continuous if f and g are continuous. That is, two functions, if they are continuous, then their sum, their subtraction, their product, their division, they only one thing you have to remember, that denominator should not be 0. These things will be continuous. So here gx sin x, hx, cos x are continuous function. These two are continuous function. If mark is given more, then you have to show this one, that the sin x, how it is continuous, cos x, how it is continuous function. Therefore, then by theorem, we will write fx is equal to gx plus hx is continuous function. So this is your answer. If fx can be written as sum of two continuous functions, then their sum is continuous. So this is our first part of the question number 21. Now number 2, it is similar like that, only here given as minus sign. So we will proceed similar way. Only fx you have to write as gx minus hx. Then of course you will find this is your answer of the question number 2 of Roman 2 of 21. So you see this can be written in this way. Here fx is given as sin x minus cos x. So definitely that as difference is also continuous, difference of two continuous function is also continuous. So that's why our fx which is also continuous. Now we will proceed our question number. I think they have given ABC, so I will write this one. Here, if it is sin x into cos x, so this will be also like that. So see, same way you have to write the answer. I am showing this way because if you know the answer, one answer you can remember also. You can easily place your answer. Presentation is also a matter. So that's why I have written in this way. So this is our total question number 21. A, B, C, all we have done. Now question number 22. That is discuss the continuity of this one. That I want to give as a homework. So I will leave because it is similar like that of fx equal to sin x. Here fx not given, it is fx cosine, cos x, sec, cotangent. So of course it is of different way we will present. Now question number 23. Find all the points of discontinuity of f where fx equal to sin x by x if x less than 0 and fx equal to x plus 1 if x greater than equal to 0. So how to show that this is continuous or discontinuous? So now we proceed to the question number 23. Question number 23 we are going to do. Here first I will write this fx. Fx they have given as two values. One is sin x by x. X is less than 0 and another is given x plus 1 if x is greater than or equal to 0. So now how to do this sum? Here for x less than 0 this is value given. For greater than 0 this is given. Now for less than 0 it is what? Rational function, that is continuous function divided by continuous function. So we write for x less than 0 fx is continuous. Why continuous? Because sin x is continuous function, x is also continuous function. If we divide a continuous function by another continuous function, then resultant function is also continuous. So you will find this thing is continuous. For x greater than 0, I have not written equal to. Fx is again continuous. Here why continuous? Because it is polynomial function. It is what? A polynomial. X plus 1 is polynomial function. So that's why you can say it is continuous. So we have no problem in less than 0 and greater than 0. We have problem only for x equal to 0. So we will check whether our function is continuous at x equal to 0 or not. For that we will write first LHL limit x tends to 0 minus fx. 0 minus means little less than 0. So we will write limit x tends to 0 fx, value of fx when x little less than 0 is sin x by x. See, limit sin x by x when x tends to 0, its value is 1. We know in limit, in class 11 we have learned that one, that sin x by x when x tends to 0 is 1. Now write in limit fx x tends to 0 plus. 0 plus means little greater than 0. So for that only x greater than 0 fx is x plus 1. if we remove this limit, x we will to replace by 0, 0 plus 1 is 1. So we left 0. So LHL is 1, RHL is also 1. Now what about F0? F0 means x is 0. If we take x is 0, then fx is this value. So here you have to put 0 plus 1, so 1. So what we get? LHL equal to RHL equal to F0. Therefore, fx is continuous at x equal to 0. And not only this, fx is continuous for all the real number. Therefore, fx is continuous function. That is, no discontinuous point is there in fx. So this is our question number 23. 23 is what? Like that only. Now we will move to question number 24. Question number 24 is, define f, determine f if f defined by fx equal to x square sine 1 by x if x not equal to 0 and fx is 0 if x equal to 0 is a continuous function. Is continuous function or not, that is our question. That is, in question number 24, fx, which is given as x square sine 1 by x when x not equal to 0 and 0 if x equal to 0. That we have to check that whether it is a continuous function or not. Here, if we consider x less than 0 or x greater than 0, then we have to think about this. Both are continuous, so their product is also continuous. So it is no problem. There is no problem in telling that for x less than 0, greater than 0, there is what? It is continuous. So now we will check for this x equal to 0. For x equal to 0, limit fx x tends to 0. I have written this one, not LHL RHL, because here LHL RHL no need to write. That is, if you can write also, but I found it is useless to write. So here x tends to 0 means what? X is not 0, tends to 0, gradually approaches towards the value 0. So for that, x when tends to 0, that is x not equal to 0, it is either positive, that is little less than 0, or little greater than 0. Then value of fx becomes this. Now see, we can take the limit on both the part. Limit, if we take limit of this one, this will give 0. If we put here this one, so 1 by 0 so we cannot write, but x tends to 0 does not means x equal to 0. A value which is almost 0, that is going to 0, it may be 0.000001. So whatever be the value, we are getting on something that is not undefined term. And value of sign always lies between a term between -1 and 0. It is what? A term between -1 and 1. That you have to remember. That sometimes it appears that if you put x equal to 0, then it is 1 by 0, but it is not the case, because x tends to 0 does not mean x equal to 0. Here means it is a nearly 0. That is a very nearest to the 0. That's why it is 1 by x is not undefined term. X square, if we put 0 square is 0. If we put whatever be the value, sine of any angle gives a value between from -1 to 1. Here we will get a value from -1 to 1. I have written between because it is may not be 90. So a terms from, if I write, it will be moved from this to that. Whatever be the term, if it is multiplied by 0, then it is what? A value 0. So we are getting this limit fx, x tends to 0 is 0. Now, what about f0? When x equal to 0, fx is 0. So what we get? Therefore, limit fx, x tends to 0 is equal to f0. Therefore, f is continuous at x equal to 0, or we can say fx is continuous at continuous function. So this is our question number 24. Now we will move to our question number 25. Question number 25 is like that. Examine the continuity of f where f is defined by fx equal to sin x minus cos x if x not equal to 0 and minus 1 if x equal to 0. So let's write this question. Here fx they have given as sin x minus cos x when x not equal to 0 and it is minus 1 when x equal to 0. We have to check whether this function is continuous or not. Now here again, if we consider x greater than 0 or less than 0, fx gives this value, that is other than 0, value of fx is this. Here sin x is a continuous function, cos x is continuous function. Their difference, of course, by theorem it will be what? A continuous function. So here for greater than 0, less than 0, fx is continuous. So what is our problem? Problem is at x equal to 0. So for x equal to 0, limit fx, x tends to 0, it will be limit x tends to 0, fx is sin x minus cos x. If we withdraw the limit, then x 0 if we put, then sin 0 is 0, cos 0 if we put, it is 1. So we are getting minus 1. So what is limit of fx, x tends to 0? It is minus 1. We will no need to use our LHL, RHL because LHL, RHL, it is the single value, that's why we will avoid this one. What about 0? f0 gives what? Minus 1. When x equal to 0, fx is minus 1. Therefore, limit fx, x tends to 0 is equal to f0. Therefore, fx is continuous function. Why continuous? Continuous at x equal to 0, that means it is continuous at every point x equal to 0. Now, question number 26. 26, they said, similar way, fx is given as k cos x divided by pi minus twice x if x not equal to pi by 2, and fx is 3 if x not equal to pi by 2. Here, given that fx is continuous at pi by 2, and we have to find the unknown term k. So let's write this question. So this is question number 26 is like that. Fx is k cos x divided by pi minus twice x when x not equal to pi by 2, that is 90, and it is 3 when x is 90. Given what? It is continuous, fx is continuous function. Continuous it is given, and we have to prove it is, we have to find the values of k. here fx is continuous at x equal to pi by 2. It is given. Fx is continuous at pi by 2. This implies limit x tends to pi by 2 fx. This should be f pi by 2. It is the rule we have learned that continuity, this is the way they are treating that if fx is continuous then it should be like that. Then x tends to pi by 2 fx. When x tends to pi by 2, that is x is approaching towards pi by 2 not equal to pi by 2, then fx is this one. So you have to write k cos x pi minus twice x, and f pi by 2, that is when pi by 2, this is 3 only. So that thing you have to know. Now if I take here 2 common from this one, then we will get pi by 2 minus x. If I take 2 common from this one, if you remove, then we will get automatically this denominator. Then cos x can be written as sine 90 minus x. It is the trigonometrical formula that sine 90 minus theta is cos theta, cos 90 minus theta is sine theta, tan 90 minus theta is cos theta. Like that formula is there. So I have written cos x as sine 90 minus x. Now, if I remove k by 2 in this way, outside of limit, now x tends to pi by 2 means the difference x is approaches towards pi by 2. That is, difference between pi by 2 and x is almost 0. So we can write limit pi by 2 minus x tends to 0. Instead of that, I have written, and numerator as it is sine pi by 2 minus x, pi by 2 minus x in denominator, and this side the 3. Now see, this is what? Limit sine theta by theta when theta tends to 0. This formula. Of course it is 1. So k by 2 into 1 is equal to 3. If I do the cross multiplication, it gives the value 6. So it is just opposite of this one. Unknown term given, they have given it is continuous. Its continuity formula we have placed, and we achieve the value of the k. So this is our question number 26. This way, question number 27 is given. 27 is like that. The function defined by fx equal to kx square if x less than equal to 2 and fx is 3 if x greater than 2 at x equal to 2. So we will do this one. At x equal to 2, the function is continuous given. So, and you have to find the value of k here. 3 types of sum given. It is the last type. First type is check the continuity. Second, point of discontinuity. Then sometimes they may ask to unknown terms relation. Then this type of thing, continuous they will give, and you have to find the unknown term. So this is this way 3 types of question can be formed. So here in question number 27, fx is given as kx square when x less than or equal to 2 and it is 3 if x greater than 2. Given what? Fx is continuous at x equal to 2. Fx is continuous at x equal to 2, it is given. So given fx is continuous at x equal to 2. So of course here we will not use directly because greater than 2, less than 2 different values are there. LHL is equal to RHL is equal to F2 we will use. Therefore, limit fx x tends to 2 minus, this is LHL, limit fx x tends to 2 plus is equal to F2. So we will write this one. Why? Why not previous way? Because previous the single value is given. Now it is different value. That's why we will write in this way. Tends to 2 minus means little less than 2. This one you see x less than equal to 2. So this value of fx is kx square. And here 2 plus means greater than 2. For that fx is 3. When x is 2 equal to 2, this term k into 2 square. Now if I would draw the limit k into 2 square 3, it is k into 2 square. So here repetition of k into 2 square. So we will remove one thing, no need to use this one. So what is the value of k? K becomes 3 by 4. So see, this is our question number 27. So now 28. 28 is also similar like that. The function is defined by fx equal to kx plus 1 if kx less than equal to 180. Another value of fx is given cos x if x greater than 180. And it is given, it is continuous at x equal to pi. So question number 28 we are going to do. So now when we will take these fx's kx plus 1, it is question number 28, kx plus 1 when x less than equal to 180. Another value is cos x if x greater than 180. See here fx is given two values. One is for greater than 2, greater than pi, another is less than equal to pi. Given what? Given fx is continuous at x equal to pi. It is given. Here also we will use LHL and RHL. So of course as it is continuous at x equal to pi, so we will use that formula LHL is equal to RHL is equal to Fa. X tends to pi minus Fx, limit x tends to pi plus Fx and F pi. See here, this we will write. It is LHL, this is RHL, this is Fa. X tends to pi minus, that is little less than pi. So then fx is kx plus 1, limit x tends to pi kx plus 1. Now second one, limit x tends to pi plus. Pi plus means greater than pi. Greater than pi it is our fx is what? Cos x. So this is our RHL. What about f pi? Equal to pi is this, so it is k into pi plus 1. So this is our LHL is equal to RHL is equal to this one. Now if we would draw the limit k into pi plus 1, if we put here pi, cos 180 is minus 1. Now k pi plus 1 you will find 2 times, so you remove this one. 1 you reject. Now k pi plus 1 is equal to minus 1. If you take 1 in this side, it is minus 2. So what will be the k? K is minus 2 by pi. So this is the thing. When it is given, then we can get the values of ks minus 2 by pi. Here only one thing you have to remember, that if it is this type of things less than greater than two things are given, then LHL RHL is mandatory to write. But if you find sometimes it is given such that it is only one, then you will only write this one, that is limit fx x tends to a is equal to fa. No need to write this one LHL is equal to RHL is equal to fa. Here I have written LHL is equal to RHL is equal to fa, putting the values of fx as per need of this demand. It is kx plus 1 for fx, this is cos x, and here f pi, it is k pi plus 1. 2 k pi plus 1, so you can reject one part because no need of this one. We have to, our target is to calculate the value of k. So of course we will write k pi plus 1 is equal to minus 1 because this one to minus 1. So ultimately we get this one as our ks minus 2 pi, 2 by pi. So almost we are approaching towards this one. So we left with a little sum that we will do in next day. So students, I hope that you have you understood all this explanation. Any doubt you can ask in my personal mobile number also. You are free to ask. So with that we end our today's class.